This is my first in-person show since March of 2020. It's good to see you all. Wow, this is weird. I don't know about you, but I feel weird. This is very weird. First of all, not in a bathrobe, right? Very different. It's been a weird 2 years. I could just do every presentation in my bathrobe and, questionable varieties of pants. Like I could wear pants with designs on them because nobody could see them. Who cares, Now I have to have something. It's weird. This is weird. It's just very strange for me. I got to be honest with you. I have a little bit of stage fright. I've talked to large audiences before, but for some reason, being back here on a stage before you all today, humbling and wonderful opportunity though it is, it feels just a little bit weird, but I'm glad to be here. Good morning. My name is Josh Long. I work on the Spring team. I'm a Spring developer advocate, a Kotlin, Kotlin Google developer expert, and of course a Java champion. And most importantly, I'm at your service. So should you have questions, comments, feedback, whatever, don't hesitate to reach out to me. Don't hesitate to find me on the internet. There, I'm at your disposal. My Twitter is at StarbucksMan. It's down there. LinkedIn, email. All those things work, they do work. I keep my Twitter wide open, so if you want to send me a direct message instead of just tweeting at me, you can find me there. I'm happy to answer questions. I'm a little asynchronous. I used to have the excuse that I was bouncing around from one place to another, and it was hard for me to sometimes get to my Twitter inbox. But now, it's just I've realized I'm lazy, and so it's actually it'll get done. It's just a little bit slower than maybe some people would like or have hoped, but I will respond. And my superpower is I don't know that much, but I know who knows, right? That's the important bit. I can connect you with people on the Spring team who have a much better sense of what all you might be trying to do. I have a blog. I have a book I just wrote called Reactive Spring. I'm working on an update to that. I've got lots of YouTube videos on the Spring Tips playlist under the spring.io/video that leads to our YouTube channel where you can find all sorts of stuff. Every Spring 1 event, we put all those videos, like 1 trillion hours of content. I don't know what the actual number is, probably more than 2 minutes and less than a trillion hours. I don't know, somewhere in there, right, in that range. And all those videos end up on spring.io/video. And of course, every week I publish a new video there as well, except for last week and the week before. No, sorry, last week and this week, because I'm here this week, and last week I was doing jury duty, and the week before I was in Hawaii. So, something's got to give. There's only so many hours in the day. I'm just in a podcast. Anybody here listen to the podcast? Oh, you poor schlub. Thank you so much. The rest of you, come on, that's good stuff. It's not me. The podcast is there's a freedom that comes with realizing you don't know anything, right? And so I embraced that freedom. And I said, I don't know anything, so I've just been spending as much time as I can getting people that are smarter than I to help me understand things, and they let me turn on the microphone. And so this podcast is just me talking to people that are way smarter than I am about stuff I have no business understanding or trying to understand, and usually it works. It's like that Reddit, Explain Like I'm 5. You ever go to that one? ELI5. Right? It's an actual subreddit. It's amazing. And you get great explanations on really complex topics. That's what this podcast is, except for the JVM ecosystem and Spring and all that. Okay, so good stuff. That out of the way, let's talk about edge services today. The goal here, my friends, as always, is I want to go to production, right? I always ground everything I do in terms of my desire, my deeply seated need to get to production. I want to get software into production. I want to build software intended for production. I want to be in production as much as possible. And then once I'm in production, I don't want to have to worry about it, right? And so these days, as often as not, production, of course, is some sort of infrastructure somewhere in the cloud. And then you've got services to which your clients will need to connect. And those services are what we're going to talk about today. Those services are the things that you need to care about in order for your clients to be happy. And here is where the problems come, right? So much of what we do these days is hopefully geared around production, right? Hopefully it's geared around this desire to move as quickly as possible, to get ideas from concept all the way to customer, to get them into production. And that continuous delivery sort of mindset, that modality, that creates churn. And that churn can create problems because now you have lots of services, lots of new services that are available for people to consume, and you've got to make it as easy as possible for them to get their data. So today, we're going to talk about several different patterns that you can use to create edge services, services that live at the edge of your architecture that are the first port of call for requests coming in from the outside, right? Those services are not the same as like your actual services. right? They might use a lot of the same bits, but they serve a different logical role in your system, in your architecture. And they have to deal, I think of them as kind of like your Band-Aid layer, right? There's a lot of things that you have to accommodate, a lot of different discrepancies and weirdness in the different clients that you have to accommodate to be able to make these services work. And that is the last place you can do it before they get downstream. You have a lot of different downstream services, each of which is going to have their own the capabilities, and you have a lot of different clients, and those clients are where you get into trouble. Those clients are where things get nuanced, right? Things will work differently from one client to another. There's all sorts of different clients out there, right? We've got Android and iOS, and by the way, just curious, it's 2022. I haven't seen human beings in 2.5 years. Who's using Android? Groovy, good stuff, hot sauce, rock on. What about iOS? And where's that one guy using Windows Mobile? Anybody? No? Okay, not here. Good stuff. So all these different clients, it doesn't matter what the target platform is, all these different clients have their own use case. Oh, and of course, HTML, right? Your browser-based experience these days is as often as not just as capable as your mobile proprietary platform sort of story, right? And that's a good thing. That means that you have 3 really, really interesting places that you can build clients, but they all have their own little nuances, their own distinctions, their own little qualities that make them a little bit more tricky. So what we want to do is to make it as easy as possible to surface information, to make that available for these different clients. So before we can do that, we actually need to have services worth connecting to, worth consuming, okay? So what we're going to do is we're going to go to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. We're going to go to my second favorite place on the internet, start.spring.io, and we're going to build a brand new service here. Let me refresh. There we go. We're going to build a brand new service. Take some water. Oh, that is so weird. I can hear other people in other rooms. Yeah? Oh, sorry. Zoom. Wow, this is. How's that? Yeah? Good stuff. Okay. Cheers. So, okay, good. So I'm going to go here, start.spring.io. Let me, there we go. We're going to build a brand new service. We're going to go to, oh, this is actually a little bit, can I make it a little bit bigger? Just a little bit? Maybe try the intermediate. This is my first time. I have a brand new, this is one of those brand new MacBook Pro M1 Maxes, right? And so it's got all the toppings. It's like souped up, and I can now run Slack and some other software, right, at the same time. It's got a lot of RAM. It's really good. I mean, I can run Slack and like some other Electron app, and the lights don't flicker, anymore. Is that okay? Can you still see that? Yeah. Okay. I'm gonna have to remember that. This is my first time using this laptop on somebody else's display. Okay, good. So we're gonna go here to start.spring.io. Obviously, this is my second favorite place on the internet. My first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. If you're suffering from indigestion after a long night of alcohol abuse and PHP, start.spring.io. If your children are restless and can't sleep, start.spring.io. And if you've been stuck indoors for 2.5 years, start.spring.io. So we're going to build a new service here. We're going to call this Customers. And we're going to use Java 17. My friends, this is, I don't know what the takeaway should be for this talk, except for, yay Spring, and also use Java 17. Who's using Java 17? Okay, the rest of you get on this. What are you doing? I don't even understand. It's not even a question anymore. Java 17 is technically superior in every conceivable way. It's faster, more performant, more robust, more operations friendly, it takes up less resources. It's a better syntax, more feature rich, more, it's just a better thing in every conceivable way. It'll save you money by its very use, right? It'll take up less resources in production by its very use. It is, judging by the version number alone, more than twice as good as Java 8, right? It is so, so good, and I don't understand why it's a question. I don't even understand, like, and also you can use GraalVM with it. By the way, I'm doing a talk on GraalVM in Spring next. I don't know where it is. It's in Devnexus somewhere, but that talk, you can use Java 17. It's great. I just, come on, get on this. Java 17 is good stuff, hot sauce. All right, so what we're going to do, my friends, is we're going to build a new application. I'm just going to build a service here. It's going to be a regular Spring Boot service. We're going to use the reactive web support. We'll use H2. We'll use R2DBC. We're going to use, I guess that's it, just a very simple service so that we have something with which we can talk, or to which we can talk, right? So I'm going to hit generate. We're going to go ahead and open this up in our IDE. Oh, by the way, just for those of you who don't go, let's do that. Okay, so, hello. So, take two. All right, good stuff. So this is just going to be a regular, again, the goal is not to really spend too much time on this stuff. So we're going to build a simple service that's going to manage data associated with customers, right? I'll create a little record here. This is a Java 17-ism that's just amazing. And then I'm going to create a repository. So customer repository extends reactive CRUD repository. Whoops. Okay. Managing customers whose primary keys of type integer. And then I'll have a trivial little service, right? So customer REST controller. Okay. And I'm going to inject the repository here. And voila. At get mapping customers publisher customer get return this dot customer repository find all. Okay, good stuff. So there's this. And this is just going to be a controller that returns not views, but they return payloads. So we're going to call that a response body. Let's just see if that works. You never know until you try it. Okay, so localhost customers. Oops, what did I do? Oh, did I wrong port or something? Oh, I don't have a SQL table. Fair enough. It wants me to configure a SQL database because I'm using R2DBC, which is the reactive, data access layer for that stuff. So I'll say create table, customer, ID, serial, primary key, name, var, car, 255, not null. Voila. Okay, I'm gonna hit restart. And we want some data in there as well, don't we? So let's go back here, and actually I'll just create a file called data.sql. Insert into customer name, and I need some names, my friends. I need some names. My name is Josh. Let's see. Who else can give me a name? What's your name, buddy? Well, Jonathan. Oh, yeah, I know you. No, somebody else. What is it? Pete. Okay, good. Like Parker. Okay. Like this? Correct? Okay, next. Who else? Just throw out some names. Yeah. Okay. How do you spell that? Like this? Rock on. Good stuff. Thank you. Next. What is it? Like that? Very good. All right, that's 4 names. Let's just add some people from the Spring team as well. We've got Madura, we've got Yushin, we've got Jonathan, we've got Olga. Okay, there we go. So there's 8 names. That's a nice round number. It's 8, and you can divide it by 2, and then 2 again. It's still just 2. It's just nice. I like that number. So we'll go ahead and, let's go ahead and run this application one more time. Okay. Refresh, there we go, good, it's working. So we have our customer application with all of our data in it. Good stuff, it worked. I'm happy about that. Of course it worked, it was a demo. It was always going to work. But I do want to just quickly, just briefly, ever so briefly, talk about one little thing that isn't all that particular to edge services, but I just think it's really great. When I went to the initializer, start.spring.io, I chose Spring Native, yeah? And Spring Native is a side project that allows you to take Spring Boot 2x and Spring Framework 5x generation applications and turn them into GraalVM native images. And so as a result, if I go here to customers, Maven -p, skip tests, clean package, and let's stop this for a second. Voila. That's going to create a GraalVM image out of the application for me, right? Which is nice. I don't know if you've ever used GraalVM, but this is great for if you're trying to deploy applications to a production cluster. The thing I love about GraalVM is not the startup time, which is great, of course, but what I care about is the vast reduction in footprint, right? My application, when I do this, what I'm doing is I'm taking my regular JVM application and I'm turning it into a GraalVM image using the native image compilation process. That in turn requires the use of the GraalVM AOT compiler. The AOT compiler hates your Java code. It hates it very much. It wants to throw most of it away. It looks at your code and it says, this is going to do stuff that it's going to piss me off. So it throws away all the stuff that does reflection, all the stuff that does, it looks at all the code and it determines what's reachable. What can it see that you're using, and then what can it transitively see that is being used by that, right? So if it can't determine that you're using something at runtime, it throws that code away. The result is that all the things that you do that are very dynamic, like reflection, like proxies, like resource loading, like serialization, all that stuff, it doesn't work unless you tell it about it, right? So Spring Native is a way to feed configuration into the GraalVM compiler so that it doesn't throw away stuff that you're going to need at runtime that can't be deterministically understood at compile time. OK, there's my application. Target, OK, customers, ta-da. OK, whoops, oh, security, Let's try that again. OK, there we go. So 46 milliseconds, right? The really important bit here, if I go here, I do pgrep customers, right? There's that, and I want to do Josh, env, bin, RSS by PID, right? It's 83 megs for the application's RAM footprint, right? So that's I don't know what your average JVM application takes up these days, but that could be meaningful. That could be a fifth or less, of your RAM, right? That's a very, very nice reduction for free. So whatever. If you want to learn a lot more about that, come see my second talk. That's neither here nor there, though. So OK, I've got this application running. It's here. Now I want to create another service. This time I'm going to create another service. I'll go back to start.spring.io. And here we're going to create a service called orders. Yeah, and this is going to use RSocket. And that's a reactive, it's a binary protocol created by Facebook. It's a great way to do messaging interchange, right? It's a great way for services to talk to each other. It's reactive. It's non-blocking on the wire, so you don't have to sort of add all these extra patterns to support robustness, things like circuit breakers and rate limiting, all that stuff. You just get that for free with reactive programming, right? So it's built in. So by using this, you get a protocol that allows you to do bidirectional communication, to do streaming, to do request response, to do all sorts of stuff. And in addition, you get all that robustness for free. It's also binary, so you don't have the porous, sort of heavy-natured text files, right? It's just really, really compressed data. OK, so we're going to create a service here called orders. We'll spin that up as well. So I'll go here, UA orders.zip. OK, and again, we're going to create another controller, class orders RSocket controller. And what I'm going to do is I'm just going to have a little map of my data, map of integer to a collection of orders. Now, I don't have the orders yet, so I'll create a record here called order. It'll have, for each customer, there will be 0 to n orders, right? So I'm just going to create a multi-relationship. Hi. And we'll say new concurrent hash map. Good stuff. And we're going to create a little, just going to, some sample data here. So for each customer, I think we created 8 customers, yeah? So what I'm going to do is I'm going to say for var customer ID equal, whoa, what is that? 0, is that right? No, I want it to be 1. Customer ID is less than or equal to 8, customer ID plus plus. And then for each one of those, I'll just create a random number of orders, right? So orders equals new array list of order for, and then I want the var order count equals math.random times 100. Yeah, OK, int. Voila. And with that, I'm going to say for var I equals 0, I is less than order count, I plus plus, orders dot add, with the right spelling there, new order. and then the ID on the order, the ID here, and then the customer ID over there. So that way, if somebody asks for the different orders, I can say, give me the orders for this customer, right? It'll just give me some random stream of data there. So I'll create an endpoint here. And this time, I'm using RSocket. So it's a different protocol, but it's the same controller paradigm, right? But the way I would do this is I'm going to use message mapping, right? This might be familiar to you if you've ever done WebSockets using Spring. So I'll say orders, customer ID, and I'm just going to return a publisher of orders, right? Get orders for destination variable integer customer ID. And here I'll say return this.orders.get customer ID. That'll give me a collection on it, and I want to turn that into a stream. Okay, so voila. There's that. Good stuff. So we have our orders RSocket controller. I guess that's it. So we have some sample data. We want this to start up, though. This is a little different than the web HTTP support in that if you want it to start up on a certain port, you need to actually specify it. Otherwise, it won't spin up a port, a container. So let's run that now. So now I've got my two services. Now let's build our Edge service. We're going to go to the start.spring.io, and we're going to build a new service called Edge. Here, we're going to bring in Spring Cloud Gateway. We're going to bring in the reactive web support. We'll bring in RSocket. And we're going to use Spring Boot 2.7, milestone 3, to get the GraphQL support. And we're going to use Java 17. So reactive web, RSocket, Spring Cloud Gateway, hit generate, and go. Now, the goal here is to make it as easy as possible to accommodate clients that are coming in and want that data. Remember, I've, for arbitrary reasons, created two different services here, one using HTTP, the other one using RSocket. That's our first problem. You're not going to very often have a completely homogeneous sort of deployment of services. They're going to have different protocols and all that stuff. So you want to centralize all of that complexity in one place. That's your Edge service. As your clients connect to your Edge service, they don't want to know that one thing is speaking RSocket and the other one's speaking HTTP and whatever. That shouldn't be their problem. The client, remember, is going to be bandwidth constrained. It's going to be, you know, you just don't know. You might have an iPhone client going through a tunnel, right, on 3G somewhere. You know, you don't know, and it's not fair to say you need to speak RSocket to this service and you need to speak HTTP to that one. So you want to funnel everything through this Edge service, which can adapt the view of the data and provide it to the client. This is useful for a lot of reasons. I mean, first of all, because you don't want to force every client to learn to speak all these different protocols. But second of all, because network threads are expensive and inefficient, right? If you're in a browser, an HTML browser, you can't create thousands of arbitrary network connections per tab, right? There's an actual upper limit. It changes seemingly every year, but there's a hard limit. You can't just make as many requests as you want. At some point, if you make too many requests, they start to get serialized. So you can't get the next response until you've finished the first one. So you want to make sure that when you make that one request, you get as much data back as you can at a time. The other thing is it's expensive, right? Network connectivity is expensive. You don't want to deprive the user's battery of resources and network connectivity and all that stuff. It costs battery and power. So be kind to them. You know, reduce the number of communications as much as possible. So here, we're going to create an Edge service. And the first thing that you might do is to use something like an API gateway. We've got something called Spring Cloud Gateway. How many of you have heard of Spring Cloud Gateway? OK, good stuff. Spring Cloud Gateway is an API gateway. I would say it's certainly more powerful than something like an Nginx, but maybe it's not fully as all-encompassing as something like Apogee or something like that, right? It serves a nice middle ground where it does 99% of what you want to do, but there are some use cases, I'll be the first to admit, it just doesn't do, and that's fine. But you'd be surprised what you can get done by using Spring Cloud Gateway. Spring Cloud Gateway is just a Java library here, right? But we do have a paid, non-open source, completely different discussion technology called Spring Cloud Gateway for Kubernetes, and that is basically it's a controller. It's an ingress controller for your cluster. And you can use the same rules and the same engine, same components here to forward all requests into the system. Okay. All right. So we're going to create a Spring Cloud Gateway application here. Route locator gateway, and the DSL you just build a route locator builder RLB, and the goal here is to build a chain of routes, and these routes describe how requests intended for this service. This is our third service. This is going to run on port 9999. We're going to describe how routes intended for that service get processed and then forwarded on to some downstream service. So remember, we have one HTTP service. We have two services total. One is RSocket, one is HTTP. But this one, we're going to forward the request onward to the downstream service running on port 8080. So I'm going to say that I have a route spec. I'm going to say when the request comes into this path, let's say proxy, right? I want to send that request onward to localhost 8080/customers. Okay. Now the problem is that this route is going to take the request as it's come in and forward it completely unadulterated to the downstream service. Well, of course, if the path on the incoming request is /proxy, it's going to end up sending /proxy to /customer. So it's going to be, /customers /proxy, which doesn't exist, right? So that's not going to work. We need to change the request as it's arrived, and we can do that through the use of filters. And this is the power of Spring Cloud Gateway. These filters allow you to introduce all sorts of think of it like a network cross-cutting concern, right? And by the way, that's one of the real superpowers of HTTP, right? When it was created, when the actual, when we talk about REST, one of the reasons we talk about REST is because it builds on HTTP, and HTTP has a built-in layering model. Right? I can introduce as many network hops, in theory, I can introduce as many network hops in between the client and the downstream service as I want, and none of them need to be the wiser. I can introduce, and what that means is I can have proxies, right? It's built into HTTP that you can do that. It's fine to do that. And so obviously there's some practical limitations because of the way that certain proxies work and different implementations, but in theory that should just work fine. I can take any HTTP request, send it to some service, and it can send it to 5 others that weren't there in the beginning, and then that can ultimately get routed to the downstream service for which it's intended. So I can add things to this HTTP request with these filters. So let's say I want to add a header. Maybe I want to support cores, right? Okay, great. Access control allow origin, great. Okay. Let's say I want to set the path to be customers. So I'm taking the existing path of .proxy, and I'm turning it into /customers, great. Maybe I want to do a redirect, based on a certain status code, or maybe I want to do a rate limiter, right? I can do that. What if I want to do a circuit breaker? I can do that kind of stuff. The rate limiter is kind of an interesting thing as well. If you have Redis, do we have enough time for that? Probably not. But if you have Redis and Spring Security, you can use this rate limiter to automatically limit the number of requests that are intended for the downstream service. This is great. There's 2 use cases that I think people have, right? One is there's an absolute upper bound, right? I can't afford to have more than n number of requests hitting this downstream service. It doesn't matter where they're coming from. It just n at any given time. It's a fixed upper bound, and you get this kind of thing where like mainframes, right? They're notoriously expensive to scale up. You don't just provision a new mainframe. It's very expensive. Consultants are involved. Golf games, it's bad, right? So you don't want to scale up beyond the number of the capacity that you've got in that mainframe. So you can have a rate limiter that just limits that. The other use case is maybe you're doing something more dynamic. Statistically, you probably are. It's 2022 after all. And so you've got cloud infrastructure. You're able to deploy the application. You're able to just say, spin up a new instance, please. So you're not really worried about the absolute upper bound. There's no single piece of infrastructure in your code that is limited to an upper bound for the number of requests. It's more that you're limiting. You want to limit the number of requests per user, right? You want to ensure a fair game. You don't want somebody spamming your website with requests that they're not interested in using, for example, right? And this happens a lot. You might have seasonal sales or something like that, where people come to the website and they're trying to automate their way through a number of purchases, depriving other people of actual purchases, right? That kind of stuff you want to put an end to. So you can use a rate limiter for that. And this uses Redis because that count that you have it needs to be externalized somewhere, right? If you have 10 edge services and they're load balanced, and each edge service is configured to allow, let's say, 5 requests, well then, if you add more instances, then you've got 50. You end up actually allowing 50 requests, right? So what you want is to have that counter of the number of requests that have been allowed to go through living somewhere outside of the JVM code itself, and that lives in Redis. Redis is a data structure server. It has an atomic counter that's network aware, so you can actually talk to it over the network and see that number. So this rate limiter is really convenient, but okay. We've got response headers, we've got the path. Good, let's just see what that looks like. Let's see, run, drink some coffee. Okay, so, whoops, here we go. localhost 9999 proxy. There we go. So I went to 9999 proxy, and I got the response from the downstream customer service, okay? And then if I curl this, in fact, curl -v to get the verbose output there, you can see I also got access control allow origin. So if I'm doing cross-origin request scripting, that kind of stuff, I'm doing JavaScript and I want to talk to a downstream service, I want to make sure I'm allowed to. Maybe that downstream service isn't allowed, but this, now you can make it, right? Your client can get access to it, whereas your downstream service may not. So that's one pattern. Spring Cloud Gateway, I did a Spring Tips. Oh, this is because I'm running on Apple's M1. Netty has a native thing that it can try to load. It falls back gracefully. It gracefully falls back to something that's not native. But this error is not great, and I don't know why it's still here. Anyway, you can use Spring Cloud Gateway for all sorts of different use cases here. I've only begun to scratch the surface. I did a Spring Tips, Spring Cloud Gateway video on this one. This one's oh, Apple TV. Yeah, this one's, if you get a chance, watch this one. Okay, it's a hour and a half introducing everything you've ever wanted to know about Spring Cloud Gateway. It's 71,000 views, so people like it. You can help me get across the 1 million view mark. Come on, like I'm not great at math, but there's enough of you here, right? Surely. Yeah, that adds up. Okay, so anyway, I've got Spring Cloud Gateway, and the next thing I want to do is I want to be able to, maybe Gateway isn't enough. Maybe I don't want to just forward the data. Maybe I'm not trying to take the data as it is in this. I want to change more than just the envelope of the message. I want to change the payload as well. Okay? And for this, I think reactive programming is ideal. Reactive programming is a great way to orchestrate multiple services. So here I can create a new view of the data. Rather than just forwarding the data unadulterated in the way that I've got it, I can actually change the data. And so I'm going to create a client to talk to my downstream services. So class CRM client private final, and I'm going to use the RSocket requester to talk to the RSocket service, gesund, and I'll use the web client, the reactive non-blocking HTTP client to talk to my downstream HTTP service. And this will just be a Spring Bean, right? And I need to actually initialize those two beans. I need a bean of type RSocket requester here. Okay, return builder.tcp localhost 8181. Is that right? No, 8080. Yeah, RSocket was on 8181. And I need the reactive non-blocking web client. And notice how the pattern here that you use to initialize them is both, initialize both of them. It's basically the same. You have a builder, you inject that, and you use that to build the instance of the thing you want. For the web client, I don't have anything in particular that I want to do. But for RSocket, notice that we're specifying the host and the port when we construct the client itself, right? The client itself is, once it starts up, it connects to that RSocket service, and it stays connected. This is one of the reasons why RSocket is so fast, because you keep the socket open each time. You don't have to constantly reinitialize the connection, do the handshake, and all that stuff. It's just done once on opening the application, on starting the application up, and then you get the always live connection. You can do authentication, by the way, multiple times. That's the other thing. So you can authenticate when you first connect, or you can authenticate per request if you like, right? Or you can do both, actually. You might want to do like session level and also application level connections and not the authentication. Okay, so there's my client. Let's see. We're going to create a view of the order data. So get orders for integer customer ID. Okay, return this dot RSocket requester dot route orders dot CID customer ID. And I'm going to take the data and I'm going to turn it into a type of order, right? And so I need to do something terrible, something that you should never ever do ever, not even when you're all by yourself at home and no one is looking. I am going to copy and paste code. So paste that here, and we're just going to turn the data that comes back from the RSocket service into a reactive stream of orders. And that's the RSocket data. What about the HTTP data? Well, I want my customer data. So get customers, return this .http.get URI localhost 8080 / customers.retrieve.body2flux customer. And I'm going to create a record for that as well. Customer integer ID, string name. Good stuff. Customer.class. All right, good stuff. So there's this. It's not happy with me. We don't know why. Retrieve body to flux. Oh, thank you. Good stuff. Okay. All right, so there's my two views of the data. Now, this is not, again, I'm just making two different network calls. From the perspective of the client, though, from the perspective of my code, I just get reactive streams of type order and customer. Who cares that one is using RSocket and the other one's using HTTP? But one of the nice things about using reactive APIs is that I get all these benefits. I get all these operators that make it a little bit easier to build more robust code. So I can say on error resume. When there's an exception, I just return this empty stream, for example. I can say, do a retry, right? And I want to retry, 10 times. Each time I'll wait 1 more second. I'll have an exponential backoff, that kind of thing, right? You can do timeout, right? So timeouts are great if you it's a last it's a last resort, right? I don't like timeouts generally, right? I feel like they're like a desperate attempt to make sure that you meet an SLA. But there are better ways to get that done. One of which is to use patterns that allow you to make concurrent requests. And if one of them fails, you've got the other ones going at the same time, right? And so one of those is bound to work. Obviously, the drawback to that particular approach, of course, is that you're making the same network request multiple times, so you have possible redundancies, right? You might be making the same request 3 times, so you're wasting 3 times as many resources. But if you're trying to beat an SLA, one of them will respond, even if one of them is failing or out to lunch or garbage collecting or down or whatever. Certainly not all of them are going to be down. So that pattern works very well, and it has the result of being more likely to give you a response than timeouts do, right? But either way, so the point is I can do all this. I don't have to change my code. It's just using reactive APIs, and I get that in there for free, okay? And because it's part of the reactive APIs, I can use it with the HTTP service or with the RSocket service. I don't have to change anything. I don't need other projects. I love Spring, right? But we introduced reactive APIs, in general, in 2017 with Spring Framework 5. Before that, we had, imperative blocking non-reactive APIs. And so, because we didn't have reactive APIs, we didn't have this really amazing piece of infrastructure in the core of the code base, we had to support a lot of these patterns through other projects. So we have support for things like Hystrix, and we have support for things like just a bunch of different projects. But now you just get so much of that for free with the reactive APIs, and it's just great. Okay, so I've got these 2 different endpoints. I still want to create a new view of the data to optimize for the experience that the client wants. I have, logically, 2 different services, the order service and the customer data. These are managed by different teams, and there are different protocols and all that. But logically, the customer doesn't think about their orders as being separate from their customer data, right? When I go to Amazon, if I had to go to a different website to see my orders, it wouldn't make sense. I'm logged into my Amazon account, but I have to go to some other website I have to log in again to another website to see the order data. I want that to be in one place. Logically, they belong in one place. And so I want a view of the data where I have all the customer data and all the order data, right? So get customer orders, right? And I'm going to create a new DTO to hold that data. So customer orders. And on the left, we'll have the customer. And on the right, we'll have a list of orders. Orders, okay? So this is a view of the data. It's a way that my client can see all the data. Let me see, customer orders, here we are. Okay, so I'm going to say return this.get customers, and for each customer that I get back, I want to get the order data. So for each one of those, I'm going to store the data in a tuple, right? And a tuple is a type, it's like an array where each element has its own type, okay? It's a great way to store intermediate processing data. You could create a record, but we already have tuples. So mono.zip is going to take 2 items, 2 reactive types, and it'll give me a tuple with 2 elements in it. So the first item is on the left, it's going to be the customer. And on the right, it'll be get me the order data. So customer.id, and I'm going to collect that all as a list. So if I go back here now, you can see I've got a tuple 2. I'm going to turn it into a new custom order. So tuple 2, tuple of customer of list of order, okay? So tuple customer list of order. So T1 is equal to customer, and T2, where's T2, is list of order, yeah? So on the left, I want the T1. On the right, I want the T2. Now, obviously, there are tuples for, there's pre-built types. We have tuple 1 all the way through tuple 8. So if you have more than 8 parameters, then you have to do casting, right? But for 0 to 8, you get, for 1 to 8, you get these nice, convenient pre-built types. Okay, so that works. That's very simple, very easy kind of to understand what's happening. For each customer, store 2 things in memory at the same time, a reactive stream for the individual customer, and a reactive stream representing the list of orders by calling the order service, okay? And then once I have that tuple, take that tuple, the reactive stream from that tuple, and then turn that into custom orders and return that back to the client. So let's just prove that that works. Let's just create a very simple controller here, at controller, whoopsies, controller. I'm gonna call this customer orders controller, okay, at get mapping, COs, publisher of customer orders, get, and you know what, I'll just make this a record because I'm lazy. I'm gonna say CRM client, return this.crm.get customer orders. Good stuff. So we restart, /COs, hello. What did I do wrong? Add controller. Oh, response buddy. Oh. Okay, there's my data. Something's wrong. The orders aren't coming back. What did I do? So it's calling orders.cid, passing in the customer ID. The order service, is that running? Here's the order service. Oh, okay, so I've got a index out of bounds error, I think. So what is the issue here? Oh, there's no data, of course. So this dot orders dot put, and then the customer ID, and then the orders on the right. Voila. Okay, take 2. There we go. So now I get the customer data on the top and the order data, but they're part of the same record, right? So the client doesn't have to make the network requests at the same time. And because I'm using reactive APIs, things are happening concurrently. Now this is not great, right? This is an n+1 problem still, right? What I'm doing is I'm getting the whole list of all the customers, and then that's 1. And then for each of the customers, here's the n, I'm getting the orders. But because I'm doing it reactively, I'm using non-blocking connections, I'm not forced to serialize these requests, right? The requests can be made at the same time. And so and I can afford to do that on the server side. I don't mind having lots of threads on the server side, especially when I'm not blocking. I'm not wasting threads, and it's not being done in a serialized fashion either. So this is very, very fast. The client will never, it doesn't need to know that there's an RSocket service there and whatever. Both RSocket and HTTP support something like a JOT token, right? You can do it with RSocket and Spring Security. You can do that same thing for HTTP and Spring Security. And you can handle that kind of stuff here as well. That said, we've solved this particular problem. We've created a new view of the data that'll be great for our client in this particular use case today, right now. But what happens tomorrow? Some new client comes along. They have a new view of the data that they want that doesn't match up with what we have here, right? And this is the problem that a lot of organizations have, is they create a view of the data, and they're like, it's perfect. It'll never need to change. Famous last words, right? Like, it always needs to change. That's the only constant is change, right? And so having this API, as easy as it was still work. I had to write 5, 10 lines of code, right? It wasn't hard work, thanks to reactive programming, but it's still work. And that's not going to be great. If I have to change my edge service each time a client comes along, that's going to be a problem. And so, when you look at edge services, there's Zool. Netflix had something called Zool. How many of you know about Zool? We support it in Spring Cloud as well. I don't recommend it these days because we have Gateway. But Zool had one very interesting feature, which is you could do reloadable, Groovy-based rules, right? So if you wanted to create proxies of downstream data and you wanted to make that data available, you could put in a little script and it could be reloaded without redeploying, which is disgusting. Like, it just makes me want to take a shower, Like, the idea that I could just reload stuff in my production service at runtime, it shouldn't. I don't want that, right? I want to be able to constrain what is possible while providing as much flexibility as possible. And so there's got to be a better way. So Meta, nay Facebook, in 2012 12, they had the same problem. They realized that they have different clients, and each client has its own perspective of the data, and they're constantly rebuilding the views of that data to accommodate those different clients, and that creates an unfortunate sort of back and forth that you get locked. You end up having flag day upgrades on both server and client to make that work. So they created something called GraphQL. Now GraphQL is this is the second Facebook/Meta technology I've talked to you about today. The first one was RSocket, and this one is the other one. So GraphQL they open sourced it in 2015, and it's pretty good. I'm a big fan. How many of you have used GraphQL? Good stuff. Okay, so GraphQL is, I'm all in. I can't believe I'm saying this, but I love GraphQL. So here's an example, api.spacex.land, okay? They have a GraphQL API, right? You can query everything you'd ever want to know about SpaceX. So here's a little tool called GraphQL, and you can ask them, hey, give me all the missions, all the launches rather, show me just the last 10, give me the mission name, the launch local date, the launch site, and that's a complex object which has constituent fields. So give me the field underneath it called the site name long. Give me all the links, give me the rocket data, etc. But let's say I don't care about all this stuff. Let's say I just want the mission name and I want the rocket names. I don't care about all the other stuff. Great, I can just prune the payload there, right? Let me see. There, good. So I can do that. I can get just the minimum data that I want. This is nice. I can get as much or as little data that I need from GraphQL. And the nice thing about this is I am not paying the network cost or the complexity cost, potentially, of getting the extra data that I'm not using. If I have the n+1 and it's the only way to solve the problem, then at least I know I can opt out of that because I don't have to elect to include that, right? So GraphQL is great for that kind of thing. So we have support for GraphQL. We built it in conjunction with the GraphQL Java team, right? Including a gentleman named Andres Marek who created the GraphQL Java project. I don't know if you've ever used the GraphQL Java, but it's probably the thing you've used if you've ever used GraphQL on the Java ecosystem. GraphQL Java underpins a lot of different experiences, and it was just made some, a round of headlines in the last few months because Twitter.com, they announced that their APIs had been moved to GraphQL Java, right? And so they were experiencing much faster, much more thorough, much more efficient services, right? And obviously they're handling Twitter-level scale all through GraphQL Java. And so that's the engine that powers this project called Spring GraphQL, which we've co-developed with the GraphQL Java team, okay? And so Spring GraphQL is not yet GA, I'll say that now. But look, I went to start.spring.io, and I chose Spring Boot 2.70 milestone 3. And now I have Spring GraphQL support. Well, keep in mind, we release new Spring Boot versions every 6 months, and we only do so against GA versions of code, right? So I don't know. Nobody tells me anything. I just work here, but I think it'll be GA when Spring Boot is GA, unless we've changed the policy or something. And Spring Boot, it couldn't be more than 6 months from now. When was the last Spring Boot release? It feels like a minute ago. It's been a couple months. Yeah, Spring Boot 2.6 G. In a week? Oh, okay. Yeah. So there you go. Yeah. Here's Spring Boot 2.6 is the GA version was in November, so 2.7 will be coming out 6 months from that, right? In theory, I don't know. Yeah, roughly. That's what we usually do. So I don't know. Sometime between now and the end of time, Spring Boot 2.7 will arrive, and or not. I don't know. I can't say anything. but when it does, it'll hopefully include Spring GraphQL. So check that out. So in the meantime, I want to have a GraphQL endpoint on my data, and I've already got the Spring GraphQL starter in Spring Boot 2.07, Spring Boot starter GraphQL. So I'm going to go here, and I'm going to enable GraphQL, right? So we call it graphical, right? Get it? Graphical. So there's that. It's an endpoint that gives me the same view that you just saw for the SpaceX thing. And we're going to create a GraphQL view of the data. So here I'll say class CRM GraphQL controller, yeah? And at controller. And the controller, I need to specify the schema for my GraphQL definitions, my types, okay? There's so many benefits that you get from GraphQL, one of which is that you have to have schema. So a lot of what we do with REST and HTTP is we find ways to make apparent the structure of the data that you're sending back. So you end up having like Open API and Spring Cloud Contract and just all these things to add types to HTTP and REST, which doesn't otherwise have it. Content negotiation, all these things. You use them all taken together and you say, oh, that's a masterpiece of an API. Really well done. But of course, that should have just been part of HTTP, to my mind at least, right? If you're building services, it would be nice if that was just implied. It doesn't, that kind of stuff supports discoverability, which is great when you start to build lots of services. So with GraphQL, you build a schema. So I'm going to go here, I'll create a new folder, GraphQL, and I'll create a new file here, schema.graphqls. And we're going to create a file here, type, and the root type in all GraphQL objects is a type called query. And your type has fields. These fields can be, they can just return data, or they can take parameters, or they can act like methods, or they can act like fields, but they're always just called fields. So here, my query is the root type off of which all my endpoints hang. So this is an enumeration of all the different queries that the GraphQL API for SpaceX supports. Okay? Now, we don't know where this data is coming from. This might in turn result in another network request to some other downstream service, or it might just all be in one API in a giant monolith. But the point is the client doesn't need to know or care, right? So I want to support a query for my customer data, right? And that's going to return a collection, right? If I just do that, that's a single customer. If I do that, that's a collection of customers. So type customer. And the type is going to have an ID and a name of type string, okay? Now, what about the orders? Well, I could, if I wanted to, I could duplicate what I had before and just kind of do two fields. But again, logically, I think of them as being, customers and orders. So I want that data together. So I'll create a new type here called orders. It'll have an ID and a customer ID, right? Now, I want the order data to be here under the customer. And I can do that. So I'm going to create three types, query, customer, and order. And here I'll say, since I've got a query, right, I'm going to do a schema mapping. The type name is query, and the field name will be customers. So I'll say I'm going to use my CRM client here. Okay, very good. All right, so down here, customers, yeah? So return this.crm.getCustomers. Very good. So this is going to work for my schema because it's a schema mapping for the type called query for the field called customers. But this is a very common situation. Remember, all GraphQL endpoints will have a type called query. So there's actually an optimization you can use called query mapping. So very much like the relationship between get mapping and request mapping, you have query mapping. And here I can specify the, no, that's not it. I can specify the name of the field here if I want to. But even that, I can just infer from the name of the method. So this schema mapping is identical to the effect of this right there. Okay? Both will provide the data for a field called customers for the type called query. Okay, good. So what about the order data? Well, same thing here, right? Except this time I do want to use schema mapping. So I'll say type name is equal to customer, and I'll just let it infer the name of the field. So I'll give me the orders now. So orders. Now, of course, in order to resolve the orders, I need to have a pointer to the root customer, so I can inject that there. So I'll say this.crm.get orders for customer.id. Yeah? So now I've got two different query methods, two different fields, one for the customers, one for the orders. And if the client doesn't ask for the orders, then this method doesn't get involved. It doesn't get invoked. Let's go ahead and restart this. Okay. Localhost 9999, graph IQL, good stuff. Refresh. Okay, so you can see we've got this same exact tool. I'm going to build a query for the customer data. Notice I get tab completion. There, I want the customers with just the ID. Great. I want the name. Okay, great. I get that. What about the order data? Well, if I just ask for the order data, it won't work. I need to specify what subfields I want. Okay, so customer ID, ID. But there we go. Now my client has access to the customer data and the order data, but I'm not paying the cost. If I don't have this here, this orders thing right here, it doesn't invoke that method. It doesn't bother to it's lazy loaded, right? So it doesn't resolve that data. It doesn't make the network request. I don't pay the N+1 cost unless I use it. Now, there is a way to get around that. You can actually get around the n+1 problem with something called batch mapping, right? And so here, given a list of orders, your job, batch mapping, map of customer to list of orders. So this batch mapping syntax, your job is to return a map of customer to list of orders given a collection of orders. So you can, if you have some other endpoint that you want to call and do select all the orders where the customer ID is in this range of customer IDs, that way it's just one SQL query and one request, you can do that in this way. So this will be used instead of this one down here. This is n+1, but you can get around that by just doing this. So GraphQL is very pragmatic. And again, the result is exactly the same from the client's perspective. You get the same exact experience from the client. The other thing I love about GraphQL is that there are multiple ways there's only a few ways to do things. There's a way to read data, that's called a query. If you want to read data as it's being updated in an ongoing fashion, that's called a subscription. And if you want to update data, it's called a mutation. That's it. If you understand those three things, you've just learned GraphQL. Congratulations. You can go build stuff now, right? It's not like HTTP and REST where, I love HTTP and I love REST, but how many different ways are there to update stuff, right? Do I do a put or a post? Do I do options? What kind of, do I do 201 or 200 or 202 if it's a long-lived thing? I don't care about any of this, but it's just sort of, it's loosely specified sort of rules around how to build a REST API and not offend the Rastafarians, you know what I'm saying? So I love GraphQL because it's just very pragmatic. There's only a few ways to do it, and if you don't do that, it doesn't work. But if you do it, it works great. And with that, my friends, I think we're just about out of time, actually. I just realized. So I hope you got something out of this. Who learned something new? Oh, my aching sacroiliac. Great stuff. I appreciate you all coming. Appreciate you all being here. It's been rewarding for me. I hope I don't, I hope none of us catch the virus. Some things shouldn't be open sourced, so, have a great day. I'm doing another talk on GraalVM somewhere soon, I think in the next 18 minutes or something like that. So not here, though. I think it's in another room. So thank you. Have a great day.